Hi, I'm Bram Desmet with Flanders Scientific, and in this video we're going to explore PQ calibration of the XM310K using Light Illusion's ColorSpace CMS. This video assumes some general familiarity with ColorSpace, so if you're just getting started, we suggest beginning with our video on SDR calibration of the XM310K first, which covers probe, monitor, and TPG connectivity in more detail. To start, we're going to go to the color menu on the monitor to make sure our settings are set up appropriately for the calibration we intend to perform. First, we want to verify that the color system is set to light space. Next, we will set the range to match the range of our test pattern generator. In this case, we'll be calibrating with DaVinci Resolve as our test pattern generator, and because PQ is nominally full range, we will set both the monitor and Resolve to full range. Then from the gamut selection, we will select the memory position we plan on saving LUTs to. In this case, we'll be calibrating for P3 D65 PQ, so we will set the gamut option on the monitor to P3 ST2084. We will also set the EOTF selection to ST2084. Next, we will want to ensure that the luminance selection is set to dynamic, as dynamic is required for HDR operation. We also strongly suggest performing calibration in peak optimized modulation mode, so from the video menu, verify that peak is selected. In ColorSpace, from our monitor connection profiling window, we will set the gamut selection to match the gamut selection active on the monitor. We'll set this to P3 ST2084 as we are calibrating for P3 PQ, and that was the selection we made at the beginning of this video. Next, we will select the 1D plus 3D option in this load dialog, then select Unity Bypass in the Select LUT dropdown, then press Upload. What this is doing is loading Unity LUTs to the monitor's P3 SE2084 memory position to ensure that we are starting at a neutral, uncalibrated, and native wide gamut place on the monitor ahead of profiling the display. Since we are in dynamic backlight mode, we do not need to worry about the back 1D LUT position, as that is not active or accessible in dynamic mode. The XM310K will now be operating in native wide gamut with an underlying PQ EOTF response. Because the XM310K is operating with an underlying PQ EOTF, we will want to limit our test patch generation within the hard clip cap of the display using the Patch Scale Limit Range option. We can find out what code value to use here by making sure the target gamut is set to ST2084 P3 D65 for now. Then moving to the Hardware Options tab and pulling the sliders down until the target nits value shown here is within the bounds of the display's actual peak illuminance. The XM310K is rated at 3000 nits, and this particular unit is actually measuring at over 3200 nits, but we will pull this down to just under 3000 to give ourselves some headroom, as any calibration LUT will be inherently subtractive. So here I see that when setting the RGB sliders to 222, I get a target value of 2975 nits. That works well for our needs, so we will set our limit range threshold to code value 222 when running our profiles. Now that we also know the corresponding peak nits value for that code value, we can also create a custom target color space so that our TPG and LUT generation are all aiming for the same peak value. If we have not already created a custom color space for this peak value, we can do so now by opening a Manage Spaces window in ColorSpace, selecting the default SC2084 P3 D65 space, and then clicking Modify. Once open, we will see that the gamut and EOTF type are automatically filled in for us. The only parameter we need to adjust here is the nits value listed. We will set this to 2975 nits to match the expected luminance for code value 222 that we just determined using the RGB sliders. Once that is complete, we will give this new color space an updated output name. In this case, I'll call it SC2084 P3 D65 2975 code value 222. Then I'll press Save. So now I'll return to our profiling window, and here I'll be able to find this new target in the User Color Spaces list. I'll enable that limit range option and type in the new code value of 222. Now when I use manual sliders or run any sort of preset display characterization, my test patch sets will be scaled within this range, which is under the hard clip threshold of the display. While on this tab, I'll also want to ensure that my test patch size is set to L32. With our parameters set up correctly, we can now go to the Display Characterization tab and we will select Gray Only Large as our profile type. Our profile is now being performed. Once complete, we can move to the Graph Options tab to name and save our profile. I'll call this one XM310K Unity Bypass Gray Only Large. We can now open the LUT Tools window in ColorSpace to build our calibration LUT. We will select our custom ST2084 P3D65 2975 code value 222 target as a source, and then for destination, we'll select the profile we just ran, which we called XM310K Unity Bypass Gray Only Large. An important step here is to make sure that the limit luminance max is set to match your custom ColorSpace target. So in this case, we want to change this value to 2975. We then want to name our LUT. We will call it PQD65, and then we will press Create to generate the LUT. Once generated, we need to complete one more important step. We need to click on the Adjust LUT button, then the Maths tab, and here we want to apply the inverse scale of our limit range operation. So our code value selection was 222, and because we start the test patch generation from 0, we would want to divide 223 by 256 to get our scaling factor of 0.8711. So now we type this in as red equals red times 0.8711, then green equals green times 0.8711, then blue equals blue times 0.8711 to apply our scaling value universally across all three channels. Once that is complete, we press Apply to initiate the operation. Then we click on Manage LUT and press Save. With our LUT now set up correctly, we can return to the Monitor Communication Profiling window, verify we are saving to the correct memories, and then press Upload. Our LUT is now saved on the monitor. To verify results, we will return to the Other Profiling window, click on Display Characterization, and run a verification. As you can see, our EOTF is tracking as expected, so we know that our limit range, custom target, and LUT scaling parameters were all done correctly. And that's the basic workflow for 3D LUT-based calibration to a PQ target when starting with a display operating in baseline PQ response. ColorSpace is fairly open-ended, so there are many valid customizations to this process that could be made. But we hope this video has presented ColorSpace users some baseline concepts that will be helpful. As always, if you have any questions on calibrating this or other FSI monitors, please reach out to our support team at support@flandersscientific.com. Thank you.